All right. Hello and welcome everyone to Mount Washington Observatory's Science in the Mountains lecture series. My name is Brian Fitzgerald, the Director of Education here for Mount Washington Observatory, and joining us this evening to tell us all about the Mountain Rain or Snow program is Associate Research Scientist Meghan Collins from the Desert Research Institute. All right, thanks so much for joining us for tonight's program. If you're not already familiar with Mount Washington Observatory, we are a nonprofit member-supported organization with a mission to advance the understanding of the forces that create Earth's weather and climate. And the way that we accomplish this is through operating our Summit weather station with around-the-clock weather observation and forecast services, by conducting research and product testing projects, and by developing and offering innovative educational programs. If you have questions for tonight's speaker and you want to join us through Zoom, and if you are joining through Zoom tonight, make sure you make use of the Q&A button. You can find that just at the bottom of your Zoom toolbar there. We'll take questions at any point during the program, but we will save some time at the end to make sure to get to as many as possible. So as those pop up, feel free to type those into your Q&A chat right there. If you are watching a recording or joining us through Facebook and would like to connect through Zoom next time, feel free to register for programs over at mountwashington.org. All right, well, thanks again for joining. And before we kick things off and hand it off to tonight's speaker, we will give a few poll questions here. And Meghan was kind enough to give us some great poll questions. So I'm going to launch those now. So if you are joining through Zoom, you should see some questions popping up right now. The first one, we're always curious, where are you joining from? Is it a state within New England? Is it outside of New England or perhaps outside the country? First question for Meghan. So blank are actually better than satellites at differentiating between rain and snow around the freezing point. Now, fill in that blank. Is it weather stations, people, AI technologies, or kittens? Third question here. Last winter, the Mountain Rain or Snow program received over blank. How many reports of rain, snow, and mixed precipitation from weather observers across the country? Was it 10, 20, 30, or 40,000 observations? And then finally, Mount Washington Observatory is located in which Environmental Protection Agency designated ecoregion? And these are designated for their hydroclimatic and ecological characteristics. So which ecoregion is Mount Washington located in? It's the Northeastern Highlands, the Great White Mountain region, the Granite State region, or the Boiled Dinnerland? I'll give everyone just a few more moments to make your best guesses here. I see many of you have already participated. And we'll give you another 5 seconds or so before we end the poll. 5, 4, 3, 2, 1. And all right, let's see where we ended up here. You should be seeing the very first set of results. Well, let's see, New Hampshire is well represented, just about a third of you joining from the Granite State here. Otherwise, representatives from across New England, every state included. And then almost a quarter of you joining from outside of New England. Well, welcome to all of you, regardless of where you're joining from tonight. All right, so blank are actually better than satellites at differentiating between a rain and snow around the freezing mark. Most of you, 61% of you said people, otherwise a third of you said weather station. No one took the bait for kittens. All right, surprised by that. And then let's see, last winter, mountain rain or snow received how many reports? Most of you, well, more than a third of you said 20,000, and then second most said 40,000. Okay. And then finally, what is the ecoregion that Mount Washington is located within? Just about half of you said the Northeastern Highlands, and then the rest, well, mostly the Great White Mountain region. Well, I know some of these answers. Well, I should say all of them. Meghan did give me some answers ahead of time, but we'll see what Meghan has to say. She's the expert here. And without further ado, Meghan, I'd love to welcome you to tonight's program. Thanks so much for joining us.
Brian, thanks to everyone for being here. You can probably tell I'm not from New England originally, with my boiled dinner joke. Um, but but maybe someday I'll have the opportunity to try it. So Again, thank you all for being here. My name is Meghan Collins. I'm an associate research scientist at the Desert Research Institute located in Nevada. I live at about 5,100 feet in elevation in the high desert. Our campus in Reno, Nevada is located only 35 miles from Lake Tahoe, so you can see this lovely background. And a lot of the research that we do at DRI has to do with weather and climate, water, air quality, and other earth and environmental sciences like soils, geology, and even archaeology. My background is science communication. So I am faculty of science communication at DRI, which means I work in an embedded way within research teams to make the science better for people who need it. This can look like tailoring science research to the needs of stakeholders, whether that be policy or operational use. It also can look like innovating ways to involve people in research to improve overall outcomes. And that's the focus of the presentation that I'm going to be doing today, which is mountain rain or snow. Mountain Rain or Snow is a participatory science program, which is otherwise known as citizen science, that's focused on improving the weather technologies, improving the technologies that drive our weather forecasts. So some of you may be drawn to this presentation because you're interested in weather. Some of you may be drawn to it because it's sponsored by NASA. I'm going to talk about how weather and NASA kind of intersect in a few minutes. It was great to see where everyone lives. For those of you who are in the Northeast or honestly anywhere, we'll have an opportunity for you to get involved in the project if you want to become a community observer with us. And even if that's not your cup of tea, we hope that you kind of ultimately feel the effects of this work through improved forecasts and kind of improved preparedness for winter hazard and weather safety responses. So with that, let's jump in. The premise of mountain rain or snow is built on a really simple question or phenomenon. I won't be able to see your hands, but I love to hear when I'm doing a live talk, I love to hear who has ever noticed snow falling when the temperature is above freezing. Maybe you've been driving and noticed that snow is falling at 33, 34 degrees Fahrenheit, or maybe even warmer temperatures. Maybe you have a thermometer and looked outside of your home, notice the same thing. So this is the phenomenon on which the entire research project is built. Over the next few slides, I'm going to talk about the reason that phenomenon even exists. And then I'm going to talk about how it poses a challenge and how we are addressing that challenge through science. So as you might imagine, this phenomenon isn't just interesting, but it can cause a real conundrum for hydrologists, water managers, weather forecasters, and even emergency managers to estimate how much winter precipitation falls as snow. And also, are we prepared for the type of precipitation that's falling? So it can make life difficult in the winter. Why does this happen? I will explain. So this phenomenon is not a change to the laws of physics. Water freezes at 32 degrees Fahrenheit and freezes or melts depending on the direction the temperature change is happening. But the reason that we sometimes see snow falling at warmer temperatures is because snow forms in layers of the atmosphere high above where we live, work, and play, generally warmer. So as the snow falls through those continually warming layers of the atmosphere, it takes time to melt. And the melt rate of those snow crystals depends in part on humidity. So in high humid environments, we tend to see the rain-snow transition happening around 32 Fahrenheit. But in lower humidity places or in a storm system that's lower humidity, we may see that temperature, that rain-snow transition happen at even warmer temperatures, sometimes as warm as 38 or 39 Fahrenheit. Um, to go into a little bit of depth about why melt rates differ, you can think about the effect that sweat has on your own skin, or on your own body's temperature, I should say. When it's hot, our bodies have adapted to sweat, which releases water, and as that water evaporates, it kind of pulls heat away from our bodies. So water acts as a kind of a heat transfer mechanism for our bodies. Those water vapor evaporates. In the case of snow crystals in the atmosphere, water vapor can also act to transfer heat towards snow crystals. So in a high humidity environment, a snow crystal might be surrounded by many more water molecules that transfer warmer air to those water molecules, causing them to melt faster. Whereas in lower humidity environments, there are fewer water vapor molecules, and so less transfer of heat to those snow crystals. So that's the complex explanation. So what's the big deal? Why do we have a large science project that does coast-to-coast community engagement with people to monitor weather around this phenomenon? Well, misidentifying the rain-snow transition, so this is a term that I used a couple times, I'll explain it in a minute, can affect our predictions of flooding, snow accumulation, avalanche hazards, and so on. So improving estimates of the rain-snow transition is really, really important. The rain-snow transition, put simply, is the elevation or the point at which rain transitions to snow in a particular storm. This is something that matters a lot to forecasters, especially if they're predicting things like freezing rain, sleet, things that can either cause damage or can be dangerous to transportation. Or even, we hear this a lot in the West, instances of rain on snow. So if there's a large snowpack and rain falls on it, it can melt, that rain can melt the snowpack quickly, causing a lot of flooding. And that's something we want to be prepared for. So currently we rely on satellites and other weather monitoring technologies involving models to estimate or predict the rain-snow transition. But they're not great, as I mentioned, at forecasting the rain-snow transition right around freezing. This can differ storm by storm and region by region, as I will share with you in a few minutes. People, as we heard in one of the poll questions, are much more accurate and consistent at differentiating rain versus snow from Earth's surface. We call these ground-based observations. So mountain rain or snow involves making ground-based observations of winter weather. We ask the question simply, what is falling from the sky right now? And with those simple observations, people take about 15 seconds to beam us up an observation of rain, snow, or mixed precipitation. With those observations, as we build a very large database of these, we can help improve the technologies that drive satellite observations and other monitoring tools. So the particular satellite that our team is working on, satellite mission that we're working on right now, is called NASA's Global Precipitation Measurement Mission. You may or may not be familiar with the fact that NASA also has an Earth science focused missions. These are aiming to improve our understanding and improve quality of life on Earth. So we're not just talking about planetary science, but also life on Earth. And NASA GPM, or Global Precipitation Measurement, does struggle to differentiate rain versus snow using remote sensing technologies. In a moment, or a few minutes, I will talk about a quote-unquote report card that our team provided assessing the performance of this tool, but I want to talk about a few other things before I jump into that. So, how can we improve estimates of precipitation phase in winter? Or in other words, how can we improve the ability of our technologies to differentiate between rain versus snow? Well, the more highly accurate observations we have, the more we can ground truth or validate the performance of technologies such as by NASA, but not limited to those. So we use ground-based observations of winter precipitation from community observers all across the country. This project was founded in the Sierra Nevada region of Nevada and California, and we launched in 2020, and we have since gone coast to coast. So we have a really active observer base in the Northeast, in the Green and White Mountains, as well as in Maine. We have a lot of observers in Massachusetts, some in Rhode Island, quite a few in New York, Pennsylvania, and Ohio. We accept observations from anywhere. So even if you aren't in any of the locations that I mentioned, we would love to see what's going on in your region. So I lead the community observer engagement for the project. So I designed the entire mechanism that I'm about to describe, and I work closely with meteorologists and hydrologists to make our community observations really workable. So maintaining data quality, the consistency of observation. So I work closely with a big network of community members for this. We designed this project to have a low barrier to entry. So people, to get started, and I'll explain how this works in just a second, we use text-based communication. This enables you to reach a scientist whenever you might have a question about the project. We have a very streamlined observation protocol. You don't need to know the difference between hail and sleet, or what kind of snow is grapple to get started. We simply ask the question, what is falling from the sky right now? And there are three simple answers, three simple choices, as you can see on the right-hand side of the slide there. As a kind of benefit or kind of value add to our observers, we issue weather alerts when a storm interest is approaching their region. So we do extensive weather monitoring across the country, and we issue weather alerts via text message. People find this really helpful. They want to know what's going on in their region and appreciate the kind of push information. The data collection is done via web app, which is an app that functions through your phone's browser. So no download is needed, and it does function offline. So I'm going to slow down here because this is your opportunity to take this for a spin if you're interested. The easiest way to get started is to go in your phone, and only on your phone, not your laptop or your desktop, where you would Google something on your phone, type in www.rainorSnow.org/signup. Once that loads, you're going to see a list of different regions. You can select your region. If you're in Maine, select Maine. If you're in New Hampshire, Vermont, or Massachusetts, select Nor'easter. If you're in New York State, or Pennsylvania or Ohio, you can select lake effect. When you select your region, it's going to automatically populate a text message with your region's keyword sent to our project number. So go ahead and fire that off. And once you do, in a few seconds, hopefully, you'll receive an auto reply explaining how to get started. So all of our training for observers takes place via text message. It's a series of 3 text messages. It is that simple to participate. The first text message contains a link with the web app. And so you can see you'll have the option to sign up or continue as a guest. You have the option to install a badge or like a home screen icon on your phone, so you can access it at any time. And then you're welcome to provide information about what region you're located in, your email address if you want to find out like the results of our science. We issue newsletters sharing what we do with the community observations that are sent. When you send an observation to Mountain Rain or Snow, we also receive your location and a timestamp. So that way we know where or when it is raining or snowing. A lot of people ask, what is mixed precipitation? I think in the Northeast, you are probably the most familiar with recognizing mixed precipitation. If you have to think about it or look twice, it's probably mixed precipitation. It looks like snow that is starting to get a little mushy and melt, probably seeing a lot at this time of year, or rain that's starting to crystallize. So it's snow that's like maybe falling a little bit heavier than you would expect. or rain that's starting to take a little bit of a kind of amorphous shape. Our apps enable you to view your previously uploaded reports and submit reports offline. Okay, so I talked a lot about our coast-to-coast network so far. Last year, this is the answer to one of the poll questions, we received over 32,000 total observations from people from states all the way, Washington and even a handful in Alaska, all the way to Maine. And in between, in a second, I'm going to show a map, but we have over 1,800 active observers in our network, and we celebrate the hard work that they do every day because it is so valuable to receive these simple observations that we couldn't otherwise get. So you can see here a list of the EPA designated ecoregions, but you can also see little dots where people are reporting from outside of these ecoregions. Like I said, we welcome data from anywhere. So we have folks in Montana, Oregon, Wyoming, Colorado, California, Nevada, Utah, lots of really exciting locations from where we're receiving data. And obviously earlier I listed the states in the Northeast where we have a lot of active folks. And this is a different kind of heat map showing the density of our observations in different locations. So I've talked so far about why we do the project, the scientific phenomenon that confounds hydrologists and meteorologists. I've talked about what we're doing about it. So I've explained how we engage community members to send reports and the value of those reports. I'm next going to talk about lessons learned. So what have we learned through these data collection mechanism? I want to underscore again that this team is highly interdisciplinary. I work with hydrologists, meteorologists, and data scientists to make this work. And while it might sound like, oh, those are just different pointy-headed people, this is a really novel approach for answering this question. Briefly, if you are interested in accessing this large data set, grab a screenshot of this QR code now. We've got an extensive data processing pipeline that does QA/QC, or quality assurance, quality control, of all of our community submitted data. And then we add a number of ancillary different data types along with it. So this is a high, what we hope is a high value output that's available for anyone who works operationally or in the research space. So what have we learned so far? Mountain Rain or Snow, I mentioned, launched in 2020, and we have done numerous research studies from different angles answering this question. So the first lesson that has come out of our research is the temperature at which rain transitions to snow differs by region and even by storm event. This might be an obvious conclusion given what I've told you so far, but being able to, lesson one kind of underscores the nature of the problem and has qualified it better for the hydrology and meteorology communities. So I'm going to explain this using the analogy of skee ball, or kind of how we go about this. So I love skee ball. I hope some of you do too. Whenever I have a chance to throw quarters in a skee ball machine, I take it. If you imagine for a moment that you're playing skee ball, and you can look at this image here, you might be able to, you might be interested in what the chances of throwing, say, a 50-point score or a 20-point score are. So maybe you want to forecast what your score is going to be. If you threw 10 throws and you then plotted it, you could, maybe you got 5, this would be me, maybe 5 throws in the 10 zone, 1 in the 40, and 4 in the 30 zone, just making things up. Using this simple analogy, I might have a 50% chance of scoring 10, a 30% chance of scoring 40, and a 10% chance of scoring 50. So I just turned my throws in the real world into probabilities that that maybe could forecast into the future. We can do something really similar. Actually, let me show you my points curve here. So here's a graph. On the x-axis, we have the number of points. In this particular example, I had, and these dots don't correspond to the numbers I just gave, but the number of points here on the x-axis and the percent probability here on the y-axis of the vertical axis. So something that's plotted lower on the y-axis has a lower probability, and up here has a higher probability. In the case of my skee ball skills, I have a lower probability of scoring a 50 and a higher probability of scoring 10. So in the same way, in the same exact way, we could plot the observations that are shared with us by air temperature along the x-axis, and then the probability of seeing snow on the y-axis. So I don't have the numbers here because this is for demonstration purposes. I'll get to more specific ones in a moment. But you might imagine seeing a very low probability when, so I might just go. So when air temperatures are higher, you're going to see a low probability of snow. So 50 degrees Fahrenheit, probably you're not going to see snow. At 20 degrees Fahrenheit, very, very, very little chance you're going to see rain. Where it gets interesting is this zone in between. And that's where we're going to look for plotting the transition between rain and snow. This is a snowfall probability curve. So what is the percent chance of seeing snow? If we plot every single observation and the temperature at which it was recorded, we could draw a line and get our snowfall probability curve. So what we did in the early years of the research was to plot snowfall probability curves for different regions. I'm aware this is very small, but you have different ecoregions: the Cascades, the Central Basin and Range, Colorado Plateau, Eastern Great Lakes lowlands, High Plains, and so on. This is the Northeastern Highlands, like you said, like I showed before. Snowfall probability charts, as you can see, vary by region. So the steepness of the curve is a little bit different in different locations. This indicates if the rain-snow transition is likely to happen, how quickly, how narrow of a range, at what temperatures do we more often see snow? Are there clusters of observations in those higher temperatures or not? And what is the probability of snow at 0 degrees Celsius or 5 degrees Celsius? And you can look at that across multiple curves by taking a line up from 0 degrees Celsius. I'm not using the pointer here, but I can. Just imagine you draw a line from 0 degrees Celsius up. You see where rain transitions to snow, and you can check out the probability of that. You could also compare the 50% rain snow threshold for each graph. So that was some of our early research to just quantify and justify that, yes, rain snow transition happens differently in different regions based on these ground-based observations. Lesson 2. This is where we get into our report card for NASA. How do satellites do when it comes to identifying rain versus snow? Early on, same time frame, we compared NASA's iMerge technology. So this is an algorithm that drives the ability of NASA's satellites to differentiate between rain versus snow. We issued a report card, and I'm going to explain that here in a second. But first, I want to just tell you how this graph is laid out. So on the x-axis, you have air temperature. So just like in the previous snowfall probability curves, we have temperature on the x-axis. In this case, it ranged from -10 Celsius to 20 degrees Celsius. Along the y-axis, it's not a range. These are different regions. And the colors indicate success or agreement between satellite observations and community observations. So success rate goes in a range of, is indicated by a range of colors. So low success rates are darker blue, and higher success rates are kind of that light green. White means no data. We didn't have enough observations to be able to do a comparison at those temperatures. So let's take a look at Oh, so as you can see, the kind of pattern is that near freezing air temperatures had lower success rates, but again, they're not, there's a lot of variability across regions and even sometimes across temperatures. So let's take a closer look at the Northeastern Highlands. Your eyes might be honing in on a temperature threshold right around 1 to 2 degrees Celsius. That's the darkest blue. That's where NASA satellites and their technology struggled the most in this region to kind of estimate rain versus snow. What I just showed you is our kind of early report card from 2021 to 2023. And my colleague Guo just published a paper in December assessing 3 different satellite technologies, iMerge, MERA2, and NL-2. I know that's alphabet soup, but looking at those different reanalysis products' performance at detecting snowfall and rainfall. If you are interested in reading that paper, you can grab that QR code because it kind of gives more detail on what I've described here. And this was for a longer time period than the period I showed in those first plots. So let's move on to lesson 3. What else have we learned? We have learned that tools that estimate the rain-snow transition tend to overpredict rain. So NASA satellites, as I was talking about previously, are just one type of tool or model or technology that looks at estimating rain versus snow around freezing. There are numerous other types. And before I jump into this detail, I want to use an analogy. A model, any kind of model is a little bit like a recipe. You have inputs, just like ingredients, you have data that goes in, and then the ways that those data are arranged or work together yield your final product. So in the same way that a baker might try multiple recipes in search of the perfect loaf of bread, scientists often consider how different models perform for analyzing data based on how the data is used, how the models are constructed, and then how the end product shapes up. So my colleague Keith Jennings led a paper to compare 14 different rain-snow partitioning methods. He compared our quality controlled crowdsourced data to numerous models that you can see on the plot. These are designated by the letters on the far left axis, so B and T. The B stands for binary logistic regression, and the T stands for different temperatures. So wet bulb temperature, dew point, air temperature thresholds. Keith found that the meteorology-based methods tended to underestimate snow on average, and all 14 models tended to overpredict rain. So this is a really helpful contribution to the literature specifying exactly how much kind of accuracy and rain or snow bias there was. This paper was published in 2023, and you can grab the QR code if you're interested there. I'm going to continue to characterize not just how this has had an impact on rain snow measuring, but what we've learned about the process of collecting crowdsourced data. And that's what lessons 4 and 5 are going to be about. So lesson 4 is elevation matters for this kind of science. So as you can imagine, any scientist wants good representation of the area of the topic that they're studying to make sure that their conclusions are accurate for as large of a geographic area or as wide of a range of instances as possible. Maybe you've noticed that there are small scale geographic changes where you live that impact how you interpret the weather forecasts. This might be, you receive a weather forecast for your town, but maybe you live on a ridge and the weather that you end up seeing, is slightly different than the weather that might be predicted on, say, the Weather Channel. So in that same way, geographically and climatically diverse observations are really important for this project. I'm going to compare a couple of plots of the elevational diversity for this work. A lot of our observations in the Sierra Nevada region come from the elevation around Lake Tahoe. So you can see So on this plot, we have number of observations for the time period on the x-axis, and we have the elevation on the y-axis. So this is not a time series. This is the total number of elevations for, I think, a 3-year period. And as you can see around Lake Tahoe, we don't have a great deal of elevational diversity. A lot of people are around 5,000, just under 5,000 feet in Reno, or around lake level, which is 6,200 feet. Whereas in the Northeastern Highlands, this region did a lot better with elevational diversity, probably because there are more communities at different areas. So you can see the elevational gradient is different for the two plots, but ranging from 500 or so feet all the way up to 2,500. So this is important, and we've been encouraging people to think about ways to diversify their own elevational contributions, reporting while in transit. So reporting from the passenger seat, especially if you're traveling kind of outside population centers, you might be going over some diverse elevational ranges. Traveling to ski slopes, even reporting while skiing. I'm sure there are a lot of skiers out there, both backcountry and not. So these are some ways that we've been encouraging people to think about elevation. And I'm looking at the time, so I'm gonna try to wrap up in the next 5 minutes or so. I'm gonna get to lesson 5, and those of you who are kind of people interested might be find some real curiosity in this lesson. This is the area of the research that I have been leading. The real key to success of mountain rain or snow is the people. I mentioned before that our project has a pretty innovative way of working with our community observers. We have a two-way message communication. So if you have already signed up for the project via text message, you can reply on that thread and reach a real scientist at any time. Your reply does not go to all 1,800 people. It just goes to our team. And this, we actually published this as in part of an evaluation of our approach, because it's not something that scientists have done in the past. So we've given a lot of thought to our user experience broadly and the strategies that we use for communication and engagement of our observers. We set out to understand if our approach to working with people was working for them. And so we ask at the end of every season questions like, are our text alerts with weather information helpful for you to know how and when to submit observations? You can see 3 years of data. We have a continual increase in the number of people who say, yes, they are helpful. Likewise, the frequency of alerts have been going up. So we attribute, kind of in our evaluations, we attribute a few things to the improvements. So it's kind of this positive trend. We have continually strived to make adjustments in our observer communication, web app improvements, as well as novel recruitment approaches. We published a paper on this about 1.5 years ago. If that's of interest to you, you can grab that QR code. We send weather alerts because it is really effective in engaging people to tell us about what weather is happening. So this is just a simple plot that my colleague Keith put together kind of as a like, I wonder what it would look like if I put these data on a graph. And so you can see on the x-axis, we have days since last notification. This is basically how many days went by since we sent a weather alert via text. And you can see the bubbles represent the number of observations, and that's on the y-axis. And we have a lot of people sending observations within a pretty close time frame of those notifications. And it gets smaller, fewer observations as you go further to the right on that y-axis. And you have a lot of observations sent in like the 0 to 1 day time frame. So this just is a trend to show that most people are sending observations within a day or two of our notifications. We are really committed to sharing results with our observers. We have a series of blog style report backs. I'm speaking to you now, doing direct engagement. And we also have a photography contest, results of which will be shared pretty soon for 2025. I led a qualitative study on the effectiveness of our report backs, and I was interested to know if our report backs are meeting the expectations of our community observers. So this was a kind of exploratory study. I'm not going to go into detail on that now because I want to get to your questions. But I also shared with the scientific community what our approach to designing these report backs are, given that this is a participatory or a citizen science project. So that concludes the presentation portion of tonight's program. I want to thank all of our team members. Our team is from numerous organizations. I described what DRI was at the beginning, but we also partner with the University of Vermont, Lincoln, and the University of Nevada, Reno. I mentioned a few of my colleagues, but there are others who have made very important contributions to the project. So with that, I am going to unshare my screen and I will take questions.
All right. Thank you so much, Megan. I really appreciate that. Learned a lot myself, and in fact, questions I have myself. But before I ask any of my questions, I am so curious. There are many of you who have already submitted your questions using the Q&A button down on your Zoom screen. So please, now's a great time to submit any questions. We'll try and get to as many as we can. So, um, I know right out the gate, there are a couple questions, one from Walt and one from Ted, who referenced a couple other participatory or citizen science related programs. Walt mentioned COCORAS, and the other being MPing. Programs I'm familiar with, and like Mountain Rain or Snow, love to contribute to. I guess, what interaction or overlaps do you potentially see with some of these other really wonderful programs?
Great question. I love hearing that folks are familiar with and also contribute to these other programs. If you have not heard of COCORAS, I'll just briefly explain each one and then I'll share kind of a high level relationship. If you have not heard of COCORAS, it is a project that's working to understand kind of microclimatic variability in precipitation. So that's rainfall and snowfall and other precipitation types. COCORAS asks its observers to share how much precipitation accumulated in a 24-hour period. So people put out rain gauges and they can melt any frozen precip down and then send a report of that. So COCORAS is asking how much, and Mountain Rain or Snow is asking what. We are both working to fill in gaps in different aspects of kind of weather monitoring. We have worked closely with COCORAS to expand into areas where our respective organizations didn't have a lot of network coverage. So I have shared, for example, to our observers in the West, a call for COCORAS observers in like rural Nevada and other places where they didn't have a lot of coverage. MPing is a project that also works on precipitation phase or precipitation type. And they have a lot, we work on different aspects of kind of a similar problem. We're working really heavily in mountainous areas and as I shared with you before, kind of applying this to NASA and other hydrology related questions. And MPing is very focused on kind of the forecaster connection. So that's probably a longer answer than you expected. But we encourage you to, if you love being part of like citizen or participatory science, we encourage you to check out other opportunities as well, because there's a lot of fun things you can get involved with.
Absolutely. And that's where Megan and I got to learn about your program a little bit in a really wonderful roundtable with folks from COCORAS and MPing. And pretty much if there's like, I think the pitch is probably if there's a way you want to get involved in weather or climate science, there's definitely a program for you out there. So, and I just see even from the comments here, it looks like folks who participate in multiple. So that's wonderful. Um, a question here, a delicate one, and answer I'll just say to the best of your knowledge and ability. But Michael's asking here a little bit about obviously there's a lot that is changing at the federal landscape, especially in concern to funding from federal funders and all those sorts of things, and changes over at NOAA and forecast services, etc. Um, I guess I don't really know what the question to ask here, maybe on behalf of Michael, but I mean, potential impacts are just where, I guess, do you see overlaps with your work, I guess, with federal agencies? Certainly, you've mentioned NASA being one pretty important partner. So I guess maybe in a positive light, how do you interact with the federal government and where do, where does your work, hopefully have some impact and value with federal partners?
Great question. So, um, I may have mentioned before that all of the faculty at the Desert Research Institute, all of our research professors and our research scientists, compete for federal grants and contracts, with kind of innovative ideas for science. So we do not get paid unless we, are successful in landing grants. Those grants come from a variety of sources, federal sources like NOAA and NASA and the National Science Foundation, sometimes state level and sometimes philanthropic level. So that depending on the kind of the dimension of the science. It is probably safe to say that scientists across the country and uh, perhaps beyond are concerned about the impacts to our innovation ecosystem with reduction in federal funding. Um, Science is a public good, especially fundamental science. So basic knowledge generation, and that would not happen without the support of society.
Thanks, Megan. Really appreciate that response. Um, and also thank you, Michael, for the question as well. I've changed gears here a little bit. Question from James, this one might be a little specific and might be calling up one of your probability graphs. He's curious, zoned in on why no results in the low probability in the Middle Rockies in the graph. Are there certain, and I'll even extend that a little further, are there certain, um, I don't know, are there certain outliers or things that maybe I missed that you covered, but I'm sure there are some pieces in the different ecoregions that you looked at that
Yeah.
perhaps stand out.
I'm gonna try to grab that again and just sort of share with everyone. There's a plane going over. Hopefully you can hear it.
And while you're doing
Um,
that, I'll give a shout out to Mary, who said she's been a Coker House observer for 8 years. So way to go, Mary.
nice.
Keep it up.
Awesome. So I'm gonna click backwards. I'm so James is asking what's in the lower probability in the middle Rockies graph. Um, so here is our middle Rockies. Oh, we just probably didn't have any. This is a no data. This is like a question, simply we didn't have any observers in that particular ecoregion um, at that temperature.
Ah,
So good
okay.
question.
Yeah, I see
We
that.
must have had, snow observations up to a certain temperature, but not over.
And I guess I can see that a little bit with the opposite, I suppose, with Willamette Valley and also
Mhm.
to some degree the Cascades as well. That's
Yep.
great question, James.
Yep.
Well, thanks, Megan. There are a couple questions around, well, one from Walt, who's curious about, just for interacting with the mountain snow interface, will an iPad work or does it have to be phone?
Great question. An iPad will work. And I'm going to answer another question at the same time. There was a comment about, so our web app is designed to pull your actual location. Phones and iPads use GPS signals to indicate location.
Hmm.
Laptops and desktops use your IP address to guesstimate your location. So if a person submits an observation from a laptop or a desktop, it may be miles and miles and miles away. It may be in a different state. Based on depending on where the server is located. So that's why the web app is not enabled for a desktop or a laptop.
Okay. Yes. And thank you. I see Rick mentioned that question about entering data from a desktop browser. And certainly that's a limitation if you can't get that location specific data for sure. I will say Rick also mentioned just the encouragement of reports. So I started the program. I think it's really exciting every time I get a text. I'm like, oh, great. Okay, a storm's coming, an event. Like, I definitely want to participate. I'll say I think one of the things I learned was perhaps the helpfulness of multiple reports during an ongoing event, which I don't think I realized. I thought, oh, one and I'm done. Like, I don't know if this is too redundant or something like that to do too many of these. But I guess the other piece of that as well that Rick's calling out here too is also making sure and the encouragement of nighttime reports was not another, one of those gaps that, makes sense when you say it, but certainly not one I would have thought of.
I love that both you and Rick are bringing this up because this is really helpful for me as the kind of person who writes those text messages. So just to locate everyone, if you're not, just kind of put yourself in this imaginary space if you haven't participated in the project before. I want you to imagine that you're expecting rain or snow on Thursday. You're expecting kind of a weather system to move through. Maybe sometime mid-morning, you get a text message from us and it reminds you, oh yeah, like I was really deep in work or deep in thought, but I'm gonna look outside and see what's happening. So maybe you send an observation, and we really appreciate that. And what Brian is talking about is kind of the the encouragement from the project to maybe look up 2 hours later and send another observation throughout that storm event. So maybe multiple observations over the course of a day or a course of a few days. So me hearing like what can help support you to best like reduce the uncertainty or reduce the number of questions, that is so helpful. So I really appreciate it. And then I'm just gonna go back to Rick's comment here. Oh, encourage reports of changes. We get this question a lot. So let's imagine again, it's that Thursday and there's a weather event happening. We've encouraged you to start reporting. We encourage you to send observations when it's raining or snowing, but we're not asking you to tell us when the precipitation stops. Now, why is that? Let me answer that question for you. So I explained in the beginning that the question that mountain rain or snow is trying to answer is differentiating really finite, or excuse me, really, really fine estimations in the temperature band around freezing. So our weather monitoring technologies don't struggle to know if it's precipitating. They struggle to know what type of precipitation is falling at that temperature band around freezing. So chances are those technologies, whether it's a weather station or satellites, already know if there's precip falling. It's just simply the phase or the type, and that's why we don't have it built in to our web app. We want to make it really easy and kind of reduce any kind of questions, or like, we want to make it keep it be a 15-second time commitment, and that's why we don't have that kind of, it has stopped precipitating, because chances are those technologies also already know that. That is a really great question. I get that question a lot. And Rick, I want to thank you because those are really, I see the 3 comments. I know the audience can't see, but he made some really helpful comments, and I can tell you're like thinking about it, and I really appreciate that, because it's that kind of feedback that is so helpful to the people facing side of the project. So.
Yeah, thank you, Rick. Yeah, very astute audience here, very committed also to contributing. Many of you, including Kelly, just made a comment. Big fan of NPing and Kokoraz. A couple more questions here, just while we have you. I know we're getting up to the end of the hour here, but Ken asked the question. I know you certainly talked about, primary findings and all this, but Ken's curious, have there been any changes or developments in satellite technology relative to recognizing precipitation based in part or wholly on your work?
Great question. So we have shared these results with the scientific community via numerous publications and conference proceedings. But what you're asking, I think, is did NASA take this and make any changes? And NASA has taken it and has said thank you. And they have also said, we really appreciate this to help improve our kind of North American satellite activity. Now, can you go global, please? Let's talk about it. So that's a whole other that would be a
Your
whole other
team might need to get a little bit bigger for that one.
we would need to get a little bigger. We'd
You'll
need
be
to,
sending text messages all day and night
yeah, in exactly
in many
in
languages.
languages, and yeah. So So we will see where that goes. Great
Well,
question.
actually, that's a question that I just thought, sorry to keep pushing on, but I mean, for accessibility, I mean, are there other pieces that you've considered over time? And certainly you've been clearly thinking about the platform and how to make things as, workable for everyone, but multiple languages or other ways for folks to participate?
Yeah, it is a so we did a big overhaul this past fall for folks who might be like visually limited
Yeah.
to be able to use screen readers. Um and language is the next kind of focus, and one of the priorities of our project is to look for ways to be as reciprocal as possible. So we're asking people to share their time and effort. If we are to expand into, say, Spanish language communities, or or other languages, what can we give back?
Mhm.
Um, and that's sort of the piece that we'd like to explore, as in future chapters. So
Yeah, absolutely. All right. Well, thanks, Megan. I think we have time maybe just for one more question here. That's from Anonymous. Thank you, Anonymous. I live near Charleston, South Carolina, but grew up in the suburb of Buffalo, New York. We did get snow in Buffalo at temperatures above 32 degrees. In parentheses, they say wet snow is what we called it. We had a weather event in Charleston, South Carolina, where we got 3 inches of snow of what I would call sleet, perhaps, or freezing rain. Is this information useful? Is there a category for this?
great question. First of all, I grew up in the suburbs around Buffalo too, so thank you to our lake effect friends. Um, wet snow, yeah, a lot of the I love hearing about the kind of regionally specific weather terms. In the Northeast, I remember hearing terms like getting snotty weather, and people kind of know what they mean, like they're really cold, wet, yeah, wet and cold. So to answer your question, one of the future applications that we have been exploring of this work and the power of this community engagement network is to alert our emergency management communities about weather hazards. So freezing rain and rain on snow are two really important weather hazards that are also sometimes difficult to forecast using those same weather monitoring technologies I've talked about. So um, if I've just a few weeks ago submitted a grant application that would allow us to pilot new weather hazard features on our current app, one of which would include freezing rain, because it is valuable. So Anonymous, you are onto something. And I hope that we get that funded so that we can roll it out and help our help our operational forecasters kind of pool our collective observational power and help them out where our technologies might have a gap.
Excellent. Well, like I said, very, very astute audience we have here this evening, looking for many ways to help, and glad, hopefully, for those of you who've joined tonight, several of you will participate. I can say personally, and it's not just because I invited Megan here, not just kissing up. I joined the program. It's super easy to use. It's one of these things of many that I participate in. I'm like, oh yeah, I can do this in just a few seconds. No big deal, done, and hopefully contributed some good. So full endorsement for whatever that's worth, but really, really appreciate you, Megan, presenting about the program and sharing your expertise tonight. So thanks for coming.
I couldn't do it. I wouldn't be here without our community observer. So if you are current or new observer, like, Brian, thank you, because this project wouldn't happen without your eyes and without your efforts. So we want to just echo that thanks.
Yes, well, we love weather observation around here, so I'm glad we can do that. And thanks to all of you who did join tonight. Really hope you enjoyed the program. If you enjoyed tonight's program, don't forget this is a free program, and we want to keep it as free as possible. But certainly, if you'd like to make a donation to support programs like these, you can do that over at mountwashington.org. There is a donate button in the upper right-hand corner there. Also, if you have any thoughts about tonight's program, suggestions for future programs, please take some time. We have a Google Form survey that'll follow in the Zoom window here, and also in a follow-up email for you. And then finally, don't forget to join us for next month's Science in the Mountains program. It's on Tuesday, April 8th And that's when we'll have Mount Washington Observatory's very own research interns, and they'll be providing an overview of current research projects that include investigations of upslope or mountain snow showers, snow hydrology, a project in partnership with the Mount Washington Avalanche Center, and finally a new climate almanac project that's under development with the Appalachian Mountain Club and Hubbard Brook Research Foundation. So don't forget to register for that program, and you can watch any of our previous programs over at mountwashington.org. And we hope to see you all again soon. Thanks again, Megan. Have a great night. Take care, everyone. Bye bye.